Okay, today we're going to work on uh, Laplaceing a function that is a little more complicated, and there's a little twist in this one. So let's see how this works out. All right, we're going to evaluate the Laplace of the function sine of 2t. Okay, so as you know, with the Laplace, we go by the definition of that. Okay, and the definition states that we are going to take this definition here, 7-1 in my text. Let f of t be defined. Okay, so we're going to put in 0 to infinity e to the minus st times the ft dt. Okay, which turns into the limit as b approaches infinity of 0 to b e to the minus st ft dt. Okay, so here we recognize that f of t that we're dealing with here is the sine of 2t. So that's what we're given. Okay, so our job today. All right, so then um, so we're putting in the Laplace of sine of 2t is the 0 to infinity e to the minus st, that's boilerplate, and then we stick in the function here, sine 2t dt. Okay, so we're off and running. But remember that is next, we got to apply the limit to this, 0 to b, e to the minus st ft. So we'll see how this works out. So now we have two functions side by side in the integrand, and that's going to cause us to use integration by parts. And the formula for integration by parts, let me confirm it, is going to be here, uv minus the integral of v u prime dx. Okay, so there's your this is your integration by parts formula. Okay, you have this, it's right here. All right, so we're going to identify some things here. I chose u to be sine 2t. I guess you could do it the opposite way, you choosing the other one. I haven't done it that way. So u prime is 2 cosine 2t, taking the derivative here. Now my v prime is, I allocated e minus st, and I do the integral of that, and you need the compensation factor in front, e to the minus st, 1 over s, okay? And then I'm throwing that um, into this formula here for the integration by parts. So it's u sine 2t, v, this minus st over s, and this is a shorthand notation for just doing the limit for t between 0 and infinity. So I'm just drawing a line going 0 to infinity. Okay? Recall the definition, we need the limit. You need to apply the limit here. Okay, so everything here inside this formula that we got from the integration by parts needed to be thrown through the limit. So here we go. Then we put minus the integral 0 to infinity of v, okay, which is minus e to the minus st over s, times u prime, which is 2 cosine 2t dt. Okay, so the upper limit applied here, we're seeing this very, very often, uh, is that this guy, when you apply e to the minus s to infinity, is going to go to 0. Okay, so everything here is going to 0. Okay, because of this guy, he goes to 0. All right, so so there you go. That and the minus I took out front. Regardless, this is all gone. And this happens time and time again. This quantity here, you're looking for it as it goes to infinity, it goes away. Now we got the 0 part, though. The upper limit minus the lower limit here. So we have to put in, well, the sine of 0, as you know, is 0. It starts at 0. So you recall. Okay, there it is. It starts at 0. So we have 0 times this, and that's gone. So both of these are gone. All this stuff in the beginning is disappeared, and now we're just left back with another integral. And there we go. But I'm going to pull the 2, which is a minus and a minus is a plus. I pull 2 over s out front. These are constant. Remember, s is constant. Treat it as a constant here. And then we have our integral, okay, and 0 to infinity of e the minus st cosine 2t dt. Okay, so now we're back to another integral. And lo and behold, you know what you should do. You do integration by parts again, a second time. Okay, so here I'm identifying u as cosine 2t, and I take the derivative of that, I get 2 minus sine 2t v prime e to the minus st, and v taking the integral of this, I put the compensation in, I end up with this. Okay, so now I'm going to put it all back into the integration by parts formula, which is uv. Okay, here's my u, here's my v. Okay, and limited between 0 and infinity, my 2 over s out front of everything here. Everything gets the 2 over s out front. Okay, don't lose that constant. All right, minus the integral 0 to infinity of minus e to the minus st. What is this? This is v. Okay, and then I'm going to multiply it by my u prime, which is minus 2 sine 2t dt. Okay, so here we go. We have to apply the upper, uh, the infinity of the upper part. Okay, so again, we got this guy in here. He's hanging out in here, so he's gone. This whole section here's gone. Don't forget your 2 out front, 2 over s. All right, then your lower limit. Well, the cosine of 0 is 1. So this did not go away. You got a minus to minus, but you have 1 here, and e to the 0 is 1. So you didn't lose this. You now have it back. Okay, so, and don't forget, it's the minus here is brought in front. There it is, but it's the upper limit minus the lower limit. So these two minuses cancel out, and I end up with a plus 1 over s from this grouping here. Now I got the integral, okay, which I'm applying. I guess I'm applying the 2 over s inside here. Uh, I don't need to do that. I can just, okay, I'm pulling the minus 2 over s out front. Okay, minus 2 over s. So this is required. So you got another minus 2 over s. So I'm pulling that out front. A minus 2 over s minus a minus 2 over s. Okay, so now I end up with um, 1 over s from that, and now I have the minus 2 over s. Okay, here, which is a minus times a minus. Okay, times a minus. So it's a minus. Okay, here, right? So this becomes a plus 2 over s, but it's minus 2 over s. All right, 0 to infinity of e to the minus s sine of 2t dt. Well, guess what? Here's the entire part of this problem is this is what we started with. So we have e to the minus t times sine of 2t. Well, that's what we just ended up with right here. E to the minus t st times sine of 2t dt. Okay, so there you go. You got back what we started with. Okay, so what was that? That's the Laplace of sine 2t. So I'm just going to drop that in here. Don't leave this minus 2s out front, but that's equal to the Laplace of 2t. Okay, so sine of 2t. So now I'm going to multiply this stuff in. I get 2 over s squared minus, okay, uh, 4 over s squared, because you're multiplying the 2 over s times 2 over s. That's 4s squared. Times the Laplace of sine of 2t, where s is greater than 0. You have to remember that whenever the s is in the denominator, then s can't be 0. Anywhere in the process, you can't have undefined things going on, and that would make this undefined. So we can't do that. So s has to be greater than 0. Okay, so now I have the Laplace. I have the Laplace of sine 2t equals all this in itself over here times some stuff times itself, where s is greater than 0 applied to this, right? So now we're just going to solve for the Laplace of sine 2t. So I bring stuff around, I move stuff here and there, and I end up with the Laplace of sine 2t is is 2 over s squared plus 4, where s is greater than 0. So, strangely enough, we just using what we started with to help us find the value of uh, getting this into the Laplace domain. And there we go. The sine of 2t is 2 over s squared plus 4. And again, we're noting there's patterns going on here, and these are going to come into our assistance very soon, where we don't have to continually run the Laplace on some of these rudimentary or elementary functions. There's going to be a way we could bypass that and get right into the domain, which I'll be teaching in about 2 more lessons, and then you could resolve these soon with differential equations and get some solutions back. Okay, that's it. Tough video again. Thank you.